We're going to be talking about integration by parts when v prime's equal to 1. Let's get it. Our first example here is going to be the integral of the natural log of x. The first thing you're going to want to do for all these problems is you're going to want to figure out what your u and your dv are going to be from the problem. And all of these examples, that's going to be easy to figure out because the whole point of this video is dv equaling 1. So, u is going to equal the natural log of x, dv is going to equal 1. To find v and du respectively, we're going to integrate to find v and get x. We're going to take the derivative of the natural log of x to find du, which is 1 over x. Now there's our integration by parts formula if you forgot. And we're just going to go ahead and plug what we found into that formula. And it'll give us u times v minus the integral of u prime times v, which should be an integral that's easier to solve. And in this case, it certainly is, because x over x gives us 1, and the integral of 1 is x. So our final answer is going to be x times the natural log of x minus x and plus c. This next example, in my opinion, is a little bit trickier because we'll have to do a u substitution at the end. But the beginning's the same as the other one. We're going to plug in 1 for dv, and we're going to plug in the arc sine of x for u. And then we'll take the derivative of that to find du, which is 1 over the square root of 1 minus x squared. And the integral of 1 is x, at least with respect to x, it is. So next we're going to be just plugging into the integration by parts formula again. Nothing too out of the ordinary. So we'll have x times the arc sine of x minus the integral of x over the square root of 1 minus x squared dx. So now we're going to have to take that integral off to the side and use u substitution, with u equaling 1 over x, or 1 minus x squared, and du equaling negative 2x dx. So that'll give us a new integral of negative 1 over 2 square roots of u. So when you simplify that and you plug your x back in for u, you end up with minus the square root of 1 minus x squared and then we're going to bring that back and we're going to solve the entire thing, which will give us x arc sine of x plus, because it's minus a negative, the square root of 1 minus x squared plus c. Up next we have the arc cosine of x dx, and it'll look very similar to the last problem. So here dv is going to be 1, and u will be the arc cosine of x. dv will be, du will be negative 1 over the square root of 1 minus x squared, and v will equal x. We're going to use our integration by parts formula to plug all this stuff in. We'll get the arc sine of, or the arc cosine of x times x minus the integral of negative x over the square root of 1 minus x squared dx. We're going to use a u substitution, just like we did in the last problem, with u equal to 1 minus x squared. So du will be equal to negative 2x dx. After solving that integral, we get the square root of 1 minus x squared, and we'll plug that back in to find out our final answer, which is x times the arc cosine of x minus the square root of 1 minus x squared plus c. Our final example is going to be the integral of the arctangent of x dx. And as we have in all the examples, we're going to find our u and dv from the problem, and here dv is always equal to 1, and u is always the function. So du is going to be equal to 1 over 1 plus x squared, and v will be equal to x. And we'll plug that into the integration by parts formula, giving us x times the arctangent of x minus the integral of x over 1 plus x squared dx. We're going to do a u substitution with u equal to x squared plus 1, meaning du is equal to 2x dx, giving us a new integral of 1 over 2u du. In the end, this will give us 1/2 natural log of u, and we'll plug in our u back into the equation there. And with that done, it's time to find our final answer, which is going to be x times the arctangent of x minus 1/2 natural log of x squared plus 1 plus c.